Properly size a transient voltage surge suppressor, or TVSS. Firstly, determine the protected equipment load. Calculate the total power consumption in volt-amps of all connected equipment. This information can typically be found in the nameplate rating of each appliance or by consulting the manufacturer's specifications. Secondly, select the TVSS surge capacity. Choose a TVSS with a surge capacity measured in joules that is 2 to 3 times the protected equipment load. For example, if the equipment load is 1000 volt amps, you should select a TVSS with a capacity of 2000 to 3000 joules. Thirdly, consider the voltage protection level. Select a TVSS with a voltage protection level, or VPL, that is appropriate for the system voltage. For residential applications, a VPL of 120 volts or 1440 volts is typically sufficient. For industrial or commercial applications, higher VPL, such as 240 volts or 480 volts, may be required. Finally, choose a mounting type. Select a TVSS that can be mounted in the desired location, such as wall-mounted, plug-in, or hardwired. Ensure proper grounding for optimum performance of the device. Now, let's move on to computing the AIC rating. AIC stands for Ampere Interrupting Capacity. Firstly, determine the system fault current. It is crucial to consult with a qualified electrician to determine the maximum fault current measured in amps available at the protected location. Secondly, select the TVSS AIC rating. Choose a TVSS with an AIC rating that is equal to or greater than the system fault current. This ensures that the TVSS can handle the maximum surge current without failing and potentially causing damage to the equipment or creating a safety hazard. The formula for calculating the required AIC rating is as follows: AIC rating in kiloamps equals system fault current in kiloamps multiplied by 1.25, which is the safety factor. Using this formula and the steps provided will help ensure that the selected TVSS is appropriately sized and rated for the intended application, providing reliable protection against voltage surges. Always consult with a qualified electrician for assistance with electrical installations and to ensure compliance with local codes and regulations. Understanding the principles behind TVSS sizing and AIC rating calculations is crucial for electrical safety and equipment protection. A TVSS, or transient voltage surge suppressor, is a device designed to protect electrical equipment from voltage spikes and surges that can damage sensitive electronics. Properly sizing a TVSS involves several key steps to ensure that it can effectively handle the expected surges and protect the connected equipment. We will firstly delve into determining the protected equipment load. This involves calculating the total power consumption of all the equipment that the TVSS will be protecting. Power consumption is typically measured in volt-amps, or VAR, and can be found on the nameplate of each device or in the manufacturer's specifications. It's essential to consider the maximum power consumption of each device, rather than its typical usage, to ensure that the TVSS can handle the load under all conditions. Once the total power consumption is determined, the next step is to select a TVSS with an appropriate surge capacity. Surge capacity refers to the amount of energy, measured in joules, that the TVSS can absorb without failing. As a general rule, the surge capacity of the TVSS should be 2 to 3 times the total power consumption of the protected equipment. For example, if the protected equipment has a total power consumption of 1000 volt amps, the TVSS should have a surge capacity of at least 2000 to 3000 joules. This safety margin ensures that the TVSS can handle even large surges without being damaged. Another important factor to consider when sizing a TVSS is the voltage protection level, or VPL. The VPL indicates the maximum voltage that the TVSS will allow to pass through to the protected equipment. Selecting an appropriate VPL is crucial for protecting sensitive electronics without unnecessarily limiting the voltage. For residential applications, a VPL of 120 volts or 1440 volts is typically sufficient. These voltage levels are slightly above the standard 120 volts voltage used in most homes, providing a margin of protection against voltage spikes. In industrial and commercial applications, higher VPL may be required depending on the voltage of the electrical system. For example, In a 240-volt system, a VPL of 240 volts may be appropriate, while in a 480-volt system, a VPL of 480 volts may be necessary. It's essential to select a VPL that is compatible with the electrical system and provides adequate protection for the connected equipment. The mounting type of the TVSS is also an important consideration. TVSSs are available in various mounting configurations, including wall-mounted, plug-in, and hardwired. The choice of mounting type will depend on the specific application and the available space. Wall-mounted TVSSs are typically used in electrical panels and other locations where space is limited. Plug-in TVSSs are convenient for protecting individual devices or small groups of devices, while hardwired TVSSs are typically used for whole-house surge protection. Regardless of the mounting type, it's essential to ensure that the TVSS is properly grounded. Grounding provides a path for surge current to flow safely to ground, protecting the connected equipment from damage. Now moving on to ampere interrupting capacity or AIC rating. The AIC rating of a TVSS is another critical parameter to consider when selecting a surge protection device. The AIC rating indicates the maximum fault current that the TVSS can safely interrupt without failing. Fault current refers to the amount of current that can flow in the event of a short circuit or other electrical fault. Selecting a TVSS with an appropriate AIC rating is crucial for preventing damage to the TVSS and the connected equipment in the event of a fault. The first step in computing the AIC rating is to determine the system fault current. This requires consulting with a qualified electrician to determine the maximum fault current available at the protected location. The fault current will depend on the characteristics of the electrical system, including the size of the transformer, the impedance of the wiring, and the distance from the power source. Once the system fault current is determined, the next step is to select a TVSS with an AIC rating that is equal to or greater than the system fault current. This ensures that the TVSS can safely interrupt the fault current without failing. A safety factor of 1.25 is typically applied to the system fault current to account for variations in the electrical system and to provide an additional margin of safety. The formula for calculating the required AIC rating is as follows: AIC rating in kiloamps equals system fault current in kiloamps multiplied by 1.25. For example, if the system fault current is 10 kiloamps, the required AIC rating will be 10 kiloamps multiplied by 1.25, which equals 12.5 kiloamps. In this case, a TVSS with an AIC rating of at least 12.5 kiloamps would be required. It's important to note that the AIC rating is a critical safety parameter, and selecting a TVSS with an insufficient AIC rating can result in serious consequences, including equipment damage, fire, and electrical shock. Therefore, it's essential to consult with a qualified electrician to determine the system fault current and to select a TVSS with an appropriate AIC rating. The TVSS should be installed in accordance with the manufacturer's instructions and all applicable electrical codes. Proper installation is crucial for ensuring that the TVSS will function correctly and provide adequate protection against voltage surges. Additionally, the TVSS should be periodically inspected to ensure that it is in good working condition. Some TVSSs have indicator lights that show whether the device is functioning properly. If the indicator light is off or indicates a problem, the TVSS should be replaced immediately. In summary, properly sizing a TVSS involves several key steps, including determining the protected equipment load, selecting a TVSS with an appropriate surge capacity and voltage protection level, choosing a suitable mounting type, and ensuring proper grounding. Computing the AIC rating involves determining the system fault current and selecting a TVSS with an AIC rating that is equal to or greater than the system fault current. By following these steps and consulting with a qualified electrician, you can ensure that your electrical equipment is adequately protected from voltage surges and electrical faults.